Okay, dear students, now let us take an example of a discrete time signal. Now, to find the even and odd parts, it's again almost the same formula, but instead of the continuous signal, now I have a discrete time signal. So again, we will be first doing calculating this part, half x of n, then half x of minus n, like what we did previously. Then one time we will add them to get the even component, and second time we will subtract them to get the odd component here. Okay, so let us first calculate half x of n. Half x of n will do nothing, but it will reduce the amplitude by half. Okay, so now let us start here. Let's suppose I say that now at minus 1 the amplitude will become 1 here. At minus 1 the amplitude will become 1. At minus 2 the amplitude will become 2 here. And at 0 the amplitude will also become 2. And at 1 it will become minus 3 here basically. So that's at 1 it will become minus 3, and this signal is nothing but this is like let me write it here. This is half x of half x of n here. Okay, similarly the half x of minus n is almost you can say it's the flip signal of the half x of n. So we have the signal here. Now flip means just multiply the n axis by minus here. So it means at this signal, this 1 will go at minus 1. So I'm going to have minus 3 at minus 1 here. At 0, I'm still going to have 2 here. At 0, I'm going to have 2 here. Let me make it darker here. So you know this is a sample here. Same here. Okay, this is a sample here. And at minus 1 will become 1. So it means at 1 will become 1. And minus 2 sample will go at 2. So which is still at 2 and 2. Okay, so this is n, and this signal is nothing but this is like half x of minus n here. Okay, so now we have calculated the main thing here. Now the simple is we will add them one time to get the even part and subtract them one time to get the odd part. So for even part, what we are going to do, we will be just adding them. So addition is quite straightforward. Again, I will check at minus 2, minus 1, 0, 1 and 2. Why I'm doing it? Because the signal is starting from minus 2. This is ending at 2 here. Okay, so we will need to calculate at all samples here. So now first of all, at minus 2 the sample is 2, and at minus 1, sorry, at minus 2 the sample here is 0. So 2 plus 0 will give me 2 plus 0 will give me 2. So the sample here will be 2 here. Okay, at minus 2 the sample is 2. Okay, now at minus 1 the sample value here is 1, sample value here is minus 3. So at minus 1 what we will have, I will have 1 plus minus 3, which will give me minus 2 here. So I am going to have minus 2 here. So this is minus 2 at basically minus 1 here. Okay, next thing here is at 0. At 0 it is basically 2 plus 2 will give me 4. So at 0 I'm going to get 4 here. So let me draw it here. So I think this is at 0 here. So this will be 4 here. Then at 1, at 1 what we have, minus 3. Minus 3 plus 1 will give me minus 2. So at 1 I'm going to have, at 1 I'm going to have minus 2 here. And at 2 it means this is basically 0 here, and 0 plus 2 will give me 2 here. So I will get 2 on the other side here. So I'm going to get 2 here. In fact, red color is better. So I'm going to get 2 here. Okay, so this is basically nothing but this is my even signal here, xe of n here. Okay, so please, again, I showed you, whenever we write a discrete time signal, maybe x of n or x of minus fn, it will be same. Okay, basically this is the correct one, but maybe sometime I write like this, so don't confuse. Okay, both of them are the same here. So this is your even signal and it looks even. Okay, now let us calculate the odd symmetric here. In case of the odd symmetric or odds part, what we are going to have, same thing, but instead of addition we will be performing the subtraction here. So again, what we have, this is 2 minus, sorry, I think it's highlighted here, visible or no? No, this one. Okay, this is at here, this is 2 minus 0, so 2 minus 0 will be 2, so it means at minus 2 I will get some signal which is 2 here, at minus 2 here. Okay, now at minus 1 what we have, this is 1 here, this is 1, sorry, this is 1 1 minus minus 3. 1 minus minus 3 means we are going to have basically like 1 minus minus 3, which will be equal to 4. So I'm going to have 4 here at minus 1 here. Okay, next thing, at 0, this is 2. So 2 minus 2 is going to give me 0. So I'm going to have no sample here at 0. Okay, 0, no sample here. Let me put it here. So like this here. At 1, it is basically minus 3, like here, minus 3 minus 1. Minus 3 minus 1 will give me minus 4. So basically I'm going to have minus 4 here at 1 here. 1 here, not minus 1, at 1 here. Okay, next thing is basically at 2, which is 0 minus 2. So 0 minus 2 will give me minus 2. So basically I'm going to have minus, sorry, I'm going to have minus 2 here. So the signal here will be minus 2 at 2 here. And this signal is XO of, and here, same here, XE of n here. And this is your n here. And this looks odd. Okay, in odd what we have, whatever signal, whatever, like when for the odd we say that whatever values we have on this side, we are going to get the opposite values on the other side at exactly the same point. In case of even, we say that whatever value we have on this side, we will get exactly the same value on the other side. Okay, so this is even symmetric and odd symmetric, and this is how we calculate the even and odd parts here. Thank you. Assalamu alaikum.